My great pleasure to welcome you to the very last and very special seminar of this semester. And today we're really fortunate to have Simona Ghetti joining us. Simona is a professor of psychology at the University of California, Davis, and there she's affiliated with the Center for Mind and Brain. And she's really leading an incredible research program into the development of episodic memory, reconstructive memory, meta-memory in youth using behavioral and neuroimaging methods. And we hear a lot more about the recent findings that she has on to these important questions. Mona got a BS, Bachelor of Science degree in psychology from the University of Padua, Italy, completed a PhD at the University of California, Davis, and after a couple of years as a researcher at the National Research Council in Bologna, Italy, she returned to UC Davis, where she's been having this really productive and really incredible career as a faculty there since 2005. She's the recipient of multiple awards, including Distinguished Early Career Awards from the Society for Research in Child Development, and multiple awards from the American Psychological Society. And in her profound contributions to the field, she also co-edited an influential, important book titled Origins and Development of Recollection, that really influenced a lot of us working in this field. And what I either didn't know or didn't remember, she also edited a volume titled Victim Offender Mediation with Youth Offenders in Europe, which is focused on cross-cultural restorative justice practices. So this is just to say, it's right. This is just to say, she's really fearless in tackling range of questions and that she finds are very important. And she brings unique insights while tackling those questions, both theoretical and like really impacting the world. So we're really fortunate to have her here, and I'm really fortunate to have her as a colleague.
And friend.
And friend.
Yes, thank you. No, that was very nice. Wow, I hadn't thought about that book on restorative justice in a while, but I always found that while I do my research, there's the main research that I do, the main interest, and then some kind of research hobbies, and that was one of them. Something that I don't necessarily pursue now, but it's still fun to keep up with different questions. So today I want to tell you a little bit about the work that we have been doing in trying to characterize the early development of memory. And as Noah said, I have been long interested in the development of episodic memory, which I see, as many others, combine two levels of analysis. One is about the ability to form and store, retrieve information about our past that includes the kind of detail that makes our experiences unique. But then also, I'm very interested in how children learn to reflect on the capacity to remember. I'm interested in metacognitive processes that afford us the ability to interrogate our subjective experience and even make decisions on the basis of those subjective experiences. I don't think I have to do much convincing to a lot of this crowd that episodic memory is important, but just in case, we know that the development of a memory, episodic memory in particular, is fundamental for us to share our experiences with others. So foundational for that kind of competence, as well as anticipate future events in order to prepare. And also, more recently, there's been increased interest in understanding the extent to which the mechanisms that support episodic memory are also involved in learning of school subjects such as mathematics or just generally knowledge accumulation. And it's importantly altered episodic memory in a variety of populations, including children who suffer from chronic disease such as type 1 diabetes and asthma, two areas that I do a good amount of research on, although today is not going to be the focus of that work, but also neurodevelopmental disorders, including autism, depression, etc., and anxiety, actually. Okay, so during the course of childhood, we know that there's a vast, rapid improvement in episodic memory development. And I've been really in episodic memory, and I've been really interested in understanding how a potentially similar neurocognitive architecture may underlie very different behavioral outcomes, very different behaviors that are really different in both complexity and scope. Imagine a 2-year-old and 1-year-old reaching for a toy that was hidden moments later under a couch versus teenagers sharing with friends their most minute aspects of their experiences, right? So these are very different behaviors, and yet I think that a similar architecture underlies them, which motivates me now to look at early development to see in what way we can trace those mechanisms. Now, I spend most of my life actually studying somewhat later development using methods that require children to remember some form of item, typically pictures, that happen in contexts that vary. It could be some arbitrary association between an item and the color of a border, or the order with which items are presented, or in what corner of a screen, or in what kind of context, visual context an item is presented on. So we create variability in the input and then ask, are children able to remember not only what they saw, but also the context that went with it, that feature the episodic, unique, arbitrary element that went with it. And when you do these kind of studies, the developmental trajectory is pretty consistent. It's pretty consistently found where in childhood, here I'm starting, these are data from my own lab, in childhood between 7 and say 10, 11 years, there's a steep improvement, very rapid, but notice the variability too, right, within individual change, and then that improvement slows down into adolescence. It continues in part, but slows down. If I had my youngest children here, of course, this line would be even steeper. When I started working on episodic memory development, one of the first papers that I read was this one. This was Dan Schachter's talking about why memories of children are not like adults. And his conclusion was that, you know, their memories was akin to that of frontal patients, to which I took a little bit of, you know, I was thinking, I don't think that's right. But it was interesting to see how in these early days when we started thinking about, I mean, just to be clear, I was not in graduate school in 95. That happened a little later. I care about aging myself, but not too early in the field. Mick, you were there. I wasn't yet. I was in graduate school.
Thank you.
I wasn't yet in graduate school. I'm just saying, you know, but I do remember you giving this great talk at UC. Anyways, that was when I was in graduate school, actually. So anyways, so at this point, the idea is that frontal processes may be foundational, and that is where actually we see most of the development. But since then, a lot of us have really tried to figure out how different processes are really involved beyond, in addition to frontal mechanisms, and also trying to characterize this frontal mechanism, not just simply immature, but trying to understand in what way age differences may exist. And Noah has done some of the best work on that. So after much thinking and working, I and my great former postdoc, Yana Fandakova, a few years ago, wrote a paper where we tried to sort of provide a conceptual framework for how to think about the development of episodic memory. And we divided a level of analysis that was about memory development in terms of memory representation and the strategic processes that might support those, and also underscoring the importance of mechanisms surrounding uncertainty monitoring and subjective vivid experiences as also contributing to the final behavioral outcome of remembering the past. And I am not going to talk about that today, except for saying that after some thinking, I started wondering whether this kind of framework can also be helpful to understand what happens in earlier childhood, not just middle childhood, which is what I had studied until then, but really the early emergence of episodic memory, what happens to infants and very young children. And I think that asking this question is interesting. So I used to be really aggravated by the idea that our field, developmental psychology, is sort of obsessed with early competence. Everyone wants to understand infants, and I sort of proud myself for not studying that. And here I am, a few years later, doing the same thing. And in part is because I think that there's some really interesting phenomena that happen in very young childhood, in early childhood. One is that early memories are typically lost to infantile amnesia. We don't remember our earliest experiences, and that really led to a lot of theorizing about what might be the case, if there is actually something special that happens during that time. But at the same time, knowledge accumulates. And so we have to, whatever model that of memory we have to have is to one that reconciles these two ideas, that knowledge can accumulate despite early memories perhaps being gone. But also, there's a good deal of goal-oriented memory behavior in very young children, even things like looking for objects when prompted by, say, a family member. Where is your teddy bear? That search is a episodic search and is prompted by instructions from the world or from a contextual cueing. So I think that is another reason why it's important. And then last but not least, early neural injury may really result in increased susceptibility for memory difficulties. And that might be really more true for very young children. So for example, in a study that we just published last year, we found that early onset of asthma, so when asthma starts earlier in childhood, it alters the developmental trajectory of episodic memory. Memory improves since the onset of asthma at a much slower pace than it does for children who have even later onset of asthma or kids who don't have the disease. And right now, the NIDDK, which is the National Institute that funded, I guess, I don't know, we'll see, but that funds diabetes research, has instituted a large consortium, multi-site consortium, to study exactly what are the neurocognitive risks of type 1 diabetes in very, very young children, based on the evidence, in part from my lab, that in older children, there are neurocognitive difficulties. And so I'm very excited to be part of this consortium, and we'll see. I think we're going to learn a lot about these conditions that alter episodic memory, and that young children may be at greater risk. So again, let's talk about whether we can find evidence of the sort of building blocks of episodic memory, even in very young children. And today I'm going to try to touch upon a few studies that we've done. I don't have time to go through all of them, but I hope I'm going to give you some sort of idea of how we go about asking these questions. So first thing, when it comes to memory representations, we have considered that development brings about memory representation possibly supported by change in hippocampal processes, that changes in memory representation when it comes to precision, the extent to which memories are gain more resolution, can be distinguished from one another better. More complex, they might include more information that comes from different aspects of the experience, time, space, semantics, emotion, and they might be more flexible, retrieved across multiple cues. So gaining more ability to go back to those memories even when completely outside of context. So in young children, we try to see, I'm not an artist, but this is a brain, try to push apart two experiences that are very similar. And so, it goes without saying that it's very good for you to remember where you parked today. And if you go to the location of your car from yesterday, it's not very helpful to do that. You want to keep these similar memories separate. And what do we know about early memory representations in infancy and very early childhood? Well, we do know that infants retain some detail about specific episodes. We know that there's been a very rich, wonderful literature that has built over the past 30 years, really looking at this question. So even infants in the first year of life may retain information about the spatial position of an item on a screen, and you can measure that with eye movements. They might reproduce through imitation the order of action, the order of actions that they had learned. But what's happening in this kind of studies early on is that either the order of action, say, is not fully arbitrary. There's some sort of pre-existing relationship between the actions, say one enables the other one to happen, or there is some predictability in the environment, even about space. When it comes to retaining fully arbitrary item context association, we see clearly signature of that ability early in the third year of life. And, it's kind of interesting to ask why that is. And these memories are then retained beyond just moments after learning. Okay. So one of my favorite studies that makes this demonstration is one that Nora Newcomb published now over 10 years ago, but it's still really good. It's she had toddlers visit two environments that were identified as different, the rainbow room versus the cloud room. But but there were regularities in these rooms. For one thing, they were small rooms in a lab, but also all of them included these four containers that though were laid out differently. And in one room, a toy was hidden in one container, the blue container, and in the other room, it was hidden in the black container. Okay, so two containers are relevant for this task. Two containers are never visited, but they're there. And what she found was that it was not until early in the third year and late in the second year of life with the cue, if there was a cue presented, that kids maintained the two representations separate. Before that, they would, regardless of the room, they would search in the containers that were relevant, but we're now making the distinction between what is important here. So that's really the contextual arbitrary element of an early episodic memory. People like Lavenex and others, based primarily on non-human animal research, has argued that there are some fundamental changes in hippocampal circuitry that happen right at that time, that the monosynaptic circuitry may be already operant in even in babies, but the trisynaptic circuitry and the full integration of the dentate gyrus into the circuitry would not be fully functionally available until about the preschool years, and that would explain why there is a difficulty in keeping memory separate. So looking at how the hippocampus, so these processes are beautifully hippocampal, and they've been studied a lot in non-human animals and in adults, but in very young children, it's difficult to do that because we know that we want two things from a method. We want one that allows us to look at how the hippocampus might separate experiences, but also we want one that allows to examine the retention of memories that have not just been learned a moment earlier in a scanner. So that's a bit tricky. And then the particular age that we care about is one that is not particularly amenable to the MR environment. So if you actually work with very young infants, you may be better off, because young infants are much more less scared, especially the young ones, scared of the environment. They don't have as much motion. But here in the toddler years, which are the most interesting to us, they are scared of loud noises and the dark, which are about the defining features of a scanning environment. That's why we decided to leverage sleep in order to gain some insight. So we decided to try an approach where children had unique experiences, just like in the Newcomb study that I just showed you, and that we would associate unique experiences with sounds and new songs that children have never heard before. And then we could measure the behavior outside the scanner and then replay the sounds as a cue in the scanner to see if we would find an association between these two. And if that was the case, then we could begin to connect the dots between an emerging behavior of precision and some neural signature. So in this early study, this was with Janani Prabhakar, was a postdoc with me at the time. We had 2-year-olds visit the lab, and they would visit two rooms that were very similar. In each room, there were different toys. There was a particular teddy bear that showed up in each room. And then while children are engaged in these play activities, there's a unique song that they've never heard before that plays in each room. We wanted to make sure that children attended, or at least had the opportunity to attend, to that association between song and experience. So we had them do this same experience 3 times a week apart. And then finally, on the last visit, children were placed outside these 2 rooms. The rooms were closed. One of the songs played in the environment, and children were told to tell where they thought that the song was heard, and they could just knock at the door or point or go. And they were also given 3 little teddy bears and asked which one goes with this song. Okay. All right. So then on the night of the test, which corresponded to the 3rd visit, we had a 4th visit in a scanning room where we delivered the target song, which is the one that they were tossed on, a reversed song, so to control potentially for just the input of the melody, but being still perceptually the same, and then a completely novel song. And what we found first was that irrespective of whether the target was presented in a target of reverse, there was this bilateral hippocampal activation for the old songs compared to the new song during sleep after this experience. And then when we correlated activation for the target over the novel in the right hippocampus, we found that there was increased activation for the correct choice of room. And then if we just counted how many details, room or teddy bear together, there was a correlation between the 2. We're linking in this sample that was small but reliable the activation for a song that they learned to the memory that they had still retained after the experience in the lab. Okay, so we were gratified by this initial evidence because we thought, based on behavioral evidence that happened before, that we should find some connection between the 2. The theories were suggesting so. But and so hippocampal activation tracks early forms of memory precision because it is associated with this ability to discriminate. But this had no trivial task demands. This was a difficult task to them. When you put a 2-year-old and you make them choose between different things, there's all sorts of things that go loose. But we were still gratified. But also another issue, though, that then came to mind was that, okay, this was a situation where we were supposed to find hippocampal activation, and we did. But what about slightly earlier than the 2nd year, where there's still a little bit of discussion about if we should find this sort of connection between episodic retention and hippocampal activation, hippocampal contribution, because behaviorally, children don't seem to retain over long delays or longish delays arbitrary association. So can we find any evidence of that earlier? And so this is a different study that Lindsay Mooney did as a part of her dissertation. Now we're testing 18 to 24 months. And we do a simpler version of the task that I just showed you. This is a simpler version where in the first session, they visit 2 rooms just like they did before. They are exposed to 2 different songs just like they did before. But now the song is played while they play with a face cube, and it's a simpler, unique, discrete event. And then once they play with it for a while, the cube also appears on a screen, and so they get to click and activate the song again from the screen. And so there's a little bit of a more kind of discrete event that doesn't have the distractions of everything from the environment, where we are really trying to cue toddlers, these younger toddlers, that the song is, there happening and connected with that bass. It's not just in the background. So they do this in 2 rooms. And then the test is actually a visual preference type of test. So it's implicit in its delivery. And what they're doing is that they're presented this kind of trials where there's either the red, and in each trial there's the red or the green face, and then they hear the song that corresponds to one of the two faces, and we ask whether eye movements will direct to the corresponding face. And we do this twice. So after doing this, a week later, they come back and they do the same task again. So remember, we're looking as results here as the visual preference for the corresponding face at the presentation of a song. And what you can see here is that during session 1, the preference hovers just above chance, but a second exposure is actually helpful. And the second time when they show up and they're re-exposed to the association, now the the preference for the associated face is more robust. The night of the second session, they go to our scanning facility, and this is a block design, just like it was before, where we present songs that they've been exposed to and completely novel songs. And this time, in these young children, if you just take an univariate contrast between old and new song, we're seeing that that we still present activation, not to the same degree as the other ones, not bilateral, but still there. And just to be clear, I'm showing you the hippocampus because it's interesting theoretically, but that's not the only thing that happens to respond to differences in songs, right? So, and there are like a lot of other activation, including sensory processing and everything. So it's not just, we're not trying to argue that that's the only thing that matters, obviously. But so between 18 and 24 months, toddlers demonstrate this behavioral eye movement signature reflecting face-song associations. So we reduce the demand, the behavioral demand, the choice, the decision-making piece, but we still have a memory that is to be demonstrated not immediately after learning. So the second time is still hours later in the scanner while asleep. And again, we find greater hippocampal activation for familiar eyes compared to novel songs. And we're only known from that. So I think that when we think about hippocampal contributions to memory retention in younger children, and so longish them, not just learning, online learning, I think we have to be really careful about drawing conclusions based first on animal models, but also based on tasks that may be particularly demanding and not fully reduce the decision demand. Now, I love decision demands. Decision demands are so important because they really reveal what children do with their memories, if they have them. But sometimes if we want to try to understand the nature of a memory representation and what it might include, we need to kind of move them aside to gain some insight. We have done other studies now to look at the complexity and flexibility of memories. And in this case, I'm not going to talk about the findings, but I just want to, what we are doing essentially, we're becoming a little more kind of creative, and we try to have sort of experiences that might include a temporal aspect, so an order or kind of a spatial position, and we reward kids after doing this little task that carry spatial temporal information, and that might be retrieved under different conditions with this auditory stimulus, this song that can then help us see whether there are unique associations put together as a result of this exposure. Now, I think working with this kind of framework is helpful to interrogate early memory, but one of the things that is missing from that is the question about the durability of early memories. There's so much work about why we forget that it's sort of silly not to think about it. So early memories are lost to infantile amnesia. I said that earlier. And I want to kind of make two sort of broad stroke distinctions here about the theories that have been presented for why that happens. So there's a lot of work right now that really provides hippocampal accounts of infantile amnesia. It might be, as I said before, immature synaptic circuitry. Neurogenesis may come in and sort of reconfigure hippocampal memories, and so increasing the probability of early memories to be lost. But there are also more psychological explanations that I think could be fully integrated with the hippocampal ones, such as the emergence of self-concept and language, provide new organizational principles for early memories, thereby cueing, sort of organize them first in different ways than in pre-verbal, pre-self infants, but also providing different ways to access memories that are not as available in young children. So this is a big question about how to kind of try to figure out the durability piece. And again, though, infants and toddlers accumulate knowledge to the point that some have agreed, have suggested that the capacity to generalize precedes the capacity to form specific memories. I disagree with that. I don't think there is I don't agree. I mean, I think the evidence suggests otherwise, because I think that when the suggestion that generalization precedes specificity, meaning that toddlers are better at forming representation that really capture what's common across experiences as opposed to what's unique, is based on the idea that toddlers don't form very precise memory. So it conflates the idea of generalization with the idea of precision. So toddlers form somewhat imprecise memory that tend to retain the most important features of an object, say a ball. A toddler might remember the shape, how big it was, as opposed to the specific design on top of it. But that's not generalization, that is imprecise memory. But imprecise memories are good. Actually, a little imprecision can go a long way into supporting generalization and knowledge acquisition. So that's, I think, important. And Vladimir Slavsky and I wrote a little piece like recently to make that point. And so if this is true, though, we need to kind of look at how memories, early memories, might transform into more generalized memories over time. This is a little bit the chicken and an egg problem, but this is the idea that drives my work. And to do that, my lab and I have been turning to the idea, to episodic retention in the context of vocabulary expansion. Vocabulary is a really beautiful context to understand these mechanisms. This is the second thing that I had said that I would never study, language. So no young children, no language, and now both. Words are retained during a developmental period in which we forget a lot. So why is that? And notice that even words can be forgotten very quickly. So that's one of the myths about word learning that is been debunked time and time again. The fact that children learn words so easily, they do, but then they forget them unless something else happens. And so that process is really interesting to understand what might be going on here in early childhood. Davis and Gaskell, like over almost like 15 years ago, but more than 20 years, 15 years ago, proposed essentially a system consolidation type of model for how vocabulary expands. So taking ideas from your classic system consolidation, decide that propose that words and their reference are initially learned together through hippocampal processes, just like we form any form of arbitrary association in other contexts, and then they are consolidated after through cortical mechanisms, right? And so here, this model is helpful to think about this problem. I think that they use the MTL as a unitary kind of system, where in fact, I think to understand development is helpful to separate what might be the hippocampal contribution versus the contribution of the anterior medial temporal lobe, including perirhinal cortex, processing item-specific type of features. But this is an interesting possibility for us. And so a few years back, we did a study where we use the same type of method, learning, sleep, now to learn about words. And so what we did is we taught English sounding words to toddlers. In this study, and we since abandoned that, we had a combination of puppets and object to keep things interesting. So you were learning that this is a VAP, and you would learn that this is love. And then after a learning opportunity, we would test them in the same session. So immediately after learning, of minutes after learning, and there would be the step. There would be other object that they had seen in the learning episode and something that they knew from somewhere else. This is consistent to the layout used in other studies of word learning, and then same for the puppets. And then 1 week later, come back, same test again without further exposure to the initial labeling. And so first, both in the same session test and 1 week later, there's good retention, which tell us that if you actually engage toddlers in actual object, interacting with objects and test them about it, might actually be supporting retention even after a week delay. So well above chance for memory for the labeled items. And then on the night of the second test, scanner, presentation of several blocks of what do you see? I don't remember what it stands for. Object, see, common words, maybe the words that were known, like cup, etc. So there are like objects, unknown words, known objects is actually the known words. I don't remember why I put this. I think it's a typo. But essentially what it is words that were studied in the experiment, words that were never studied in the experiment, words that are known, like cup and train. And those are the three sort of categories. And what we found is that this is weirdly bizarre, but still we reported it. So children are tested twice, right? They're tested immediately after learning, come back a week later, tested again. That night they go and they're scanned. Okay, so what we found was memory at the 15 minutes delay, so in session 1, was associated with the difference between the learned and the novel pseudo words in the scanner. Okay, so that is the old new type of learning that we've established also with the other method. What I find peculiar is that this is the first test. Since this initial test, there is a new test that happens a week later, and then the scanning happens after the second test. And yet, the only hippocampal association that we found is this with this initial learning, even if the scanning happens later. Instead, the memory for the 1 week delay was associated with the anterior MTL in the left hemisphere, which I'm not showing you here, but also in a correlation between again memory and connectivity between the anterior MTL and this region in the medial prefrontal cortex that was lifted from another study that studied children memory for newly learned Japanese words. So we went to this other, took exactly the same coordinates and put it there, and that's what we found. So that led us to think, so this is that we absolutely needed to manipulate the delay, that this is very messy, but promising. So we started asking questions about how can we sort of dissociate the time of learning and the time of test and the kind of processes, but they might be intervening, like opportunity to relearn the words, or opportunity to generalize words, opportunity to be asked about words. So that's one of the things that we're doing right now. So we're asking, okay, how does a memory for words, how does the representation change as a function of this experience? So we have a word learning episode, which we think can be forgotten very quickly unless something else happens to elaborate on that initial meaning. But then there are evolving representations, semantic representation, and eventual integration in the lexicon could happen through repeated exposure, retrieval attempts, or even the opportunity to expand meanings and generalize. So, where am I with time?
10 more minutes.
10 more minutes, okay. Okay, so then so in this study we started asking that kind of question. This is Sabrina Kayak work, and they came to the lab, and in this first session they learned 12 new words. This is super fun for them to do. But the way they do the learning procedure for each of these items is essentially an exposure to 3 objects, actually, not just one. There's one that is the DAX, and we say, hey, look at this, it's a DAX. This is a DAX. The DAX is good for rolling. Can you roll the DAX? So what we do is repeat the label and then associate something unique about the DAX. It's an action. It gets more interactive and it's unique. Okay, after learning this, they meet a second object. Now the object is unnamed and they say, look at this. This is also good for rolling. Go ahead and roll it. So now these 2 objects have been both presented, they're both interacted with, but only one of them as a label. And then they kind of manipulate this novel object as well, because if you present a completely novel object during test, a 2-year-old will just want to play with that. So we do that procedure 12 times. And then after that, we are distributing these objects in 3 different conditions. Under the study test condition, immediately after learning all of the items, so this is not a learn test, you learn everything and then you go back and test. So with the 3 objects that were presented in every trial, we say, can you give me the DAX? Hand me the DAX. In the study situation, after learning everything, when they thought they were not done, we go back and we re-expose them and to the same procedure across the board. And then in the study-only situation, they study it once, and that's it. Okay. Then session 2 happens, and now we're asking the same type of cues for everything. Can you give me the DAX? Word recognition. What is the DAX good for? And this is a recall of the action. So this is hard. And, in some tests, kids are asked to produce the word, which with 2-year-olds is never going to happen. But rolling something and doing an action we thought was interesting and unique for each object. Okay, so I want to show you this. So first off, the study test, they're remembering these objects very well. This is the trial, so 33% is chance. And if you think that the novel doesn't matter, they're also about 50% if you want to be super strict and say it's just between 2 choices, the 2 manipulated objects. But the study 1 kids lose a lot of their memory in that week delay. And in the studies in the second session, the ones who are the only study ones perform significantly worse than both the study kids and the study test kids, who retain their memories as much as the other ones. Okay, so my current out of 1, this one, is that just started 8 months ago, is really about using this kind of manipulations to track the destiny of words and the associations with other materials as a function of when during this process of learning children are being tested and what kind of additional experiences they have after learning. So the idea would be that after several conditions in which learning is manipulated, they might reveal, like a scanning session might reveal the current state of a memory that has been recently learned versus a state of a memory that has already had the opportunity to be either forgotten or consolidated or generalized. Yeah.
So do you think the absence of the test potentiated learning is something that will come online later on in development?
It's such a good question. Do you mind if I answer it later?
Sure. Yeah.
But it's a very good question, and and I want to show you something actually that might not help but add a little piece to it. Because after this, what we also looked at was the memory for the correction rate. So is it possible? Well, what's happening to the episodic content of the surrounding of other features, such as the action. And, as I said, the 2-year-olds are not the greatest at recall. Here, they're still above chance, but practically at 4, at reproducing the correct action. And the actions were rolling, tossing, so they were distinguishable between each other, patting, so things like that. But then what we found too is that when we look at the incorrect action rate, so these are actions that were presented in a learning session, but they're reported as wrongly associated with the word, it's the study test kids who showed the most errors. Okay, so you might expect that the study test has been exposed again to the action, so they are going to have to do better. But this one I think is interesting. This increase in potential error after some opportunity to sort of think about retrieve, and raises the question of whether the process of knowledge acquisition may interfere with episodic retention. And I think that is where I want to focus a lot on, because our hypothesis about or account of infantile amnesia sort of rest on ideas of storage failure, some retrieval access problem, but I think there may be a real untested potential for massive interference that happens when children are exposed continually to new learning about words, for example, or other experiences that really interfere with the ability to retain a clear memory. So what we're doing in the next sets of studies is to learn the DAX in a context of more canonical space-time unique associations to see whether those are going to be lost at a higher rate when there's some more learning that happens in between encoding and test. So then whether the testing effect may come online later. I mean, I don't know what to respond exactly, because first of all, I don't know if we hit the correct timing, right? So you know that in adults, you don't show the testing effect, say at 5 minutes, but it gets stronger over time. So we may not be having the right timing for that, given the shrunken duration of young children's memory. So maybe it was there earlier, but not quite anymore. So that's one possibility. The other fact is that it still helps. Testing helps more than you would expect, but pure repetition is just not as advantageous or more advantageous than repetition, which then raises the question about how these different mechanisms of repetition versus other more active forms of learning might impact retention. And so we are actually looking at these kind of variables, for instance, allowing children to generalize across different contexts after learning. This is just an example, there's no data. So I think that when we think about episodic memory representation in these young children, we have to think about studying their characteristics in terms of precision, complexity, flexibility, but also figuring out how, what are the processes that intervene after learning and how they might really interfere with this early retention. Now, if time,
2 minutes.
2 minutes. So I really don't have time, so I figured that this could be a good stop. But I'm sort of tempted to tell you just a couple of things about what the work that we are doing to study the emergence of subjective memory experiences. So, that part here, the ones about meta-memory development. There's been a lot of interest in early, so I'm just going to tell you. There's been a lot of interest in recent times to asking what are the super early components of a metacognitive system. So what are the manifestations of the earliest form of error monitoring that may give rise to the subjective experience of uncertainty, for example? Now, I've studied for many years the process of subjective recollection using scales like this. Children reported that they had a very vivid memory or that they felt really confident about their memories. And so we started asking, where does this ability come from in very young children? And we know that by the time they are 3 or 4 years of age, they can do this. They can report on the confidence of their memories. And so now I'm asking, okay, if they can do verbally that kind of task at 3 or 4 years old, can I say that these behaviors that we see earlier in infancy, are they functionally relevant for that capacity? So we see them, if we take it for face value, we think that if a toddler comes to you and give them the toy after you ask, they went and just, you say, where is your teddy bear? And they launched happily with grin this big, that they may feel confident about their location. And similarly, when they give you the blank stare after you ask a question or they do this, maybe they are not that confident. But first of all, do they know that they're not confident? And that's a difficult question. But also, are these behavioral responses in any way informative for a later emerging ability to report? And this is in perception that I cannot tell you, but one thing that I want to show you actually is that we thought that gaze transitions, so weighing evidence, information seeking, that is what is the closest to that kind of like, I don't know, looking around to figure out the answer, that could be indicating some form of information seeking behavior that could be used by young children to learn how to evaluate mnemonic evidence. And it might scaffold the emergence of episodic memory. So we've just finished a longitudinal study now where we looked at 2-year-olds gaze transitions between response options in a forced recognition test and asked whether that predicted uncertainty monitoring, that is reporting higher confidence for correct answers compared to incorrect answers. And this is the last piece, is that gaze transitions in a longitudinal model that accounts for a lot of the variables that we're interested in uniquely predict this meta memory monitoring at age 3. So I really think that, and then I'm going to conclude because it's been a while since I started talking. I want to say this. I really think that when we think about very young children who are barely verbal, and we think that there's something fundamentally different between them and older children, I think we're not really getting it right. I think that we can trace some of the fundamental mechanisms of memory and subjective experience even in very, very young children who can remember fairly detailed memories, imprecise, but still using processes of episodic memory formation and retrieval, and might even explore their world, visually explore the world, at least so far visually, to learn about how to determine when memorial evidence is good, and that capacity actually has implication for later emerging capacity to reflect on their subjective experience of recollection. So with that, I will conclude. Thank you.
Take you back to vocabulary learning.
Yeah.
2 related issues.
Mm-hmm.
Kids with developmental amnesia, damage, assuming that they're not otherwise have other learning difficulties, they do language normally. They acquire vocabulary knowledge at a normal rate, even though their hippocampus is unable to support episodic memory.
Yeah.
Second, related to that is this notion of fast mapping. Which is
fast mapping, but slower retention.
Yes, but that's been argued, particularly in children, to be hippocampally independent. And there's some very controversial evidence in adults that fast mapping is hippocampally independent. Putting those 2 things together, why would one start from the premise that vocabulary accumulation is dependent on the hippocampus? The
accumulation itself, probably not. Is the initial learning that I think.
How can the initial learning be there in a developmental amnesia?
Well, I think that there are 2 things that I think. First is that that there are other ways to learn words, just like there are other ways to learn pretty much anything. So you don't need a lot of I think that processes that are just cortical learning, for example, can be completely sufficient, slower. And within developmental amnesia, learning is slower. So you can get to the same endpoint, but they require much more repetition. It's slower learning. And I think that that's key, right? So I'm not suggesting that the only way to learn words is, through a healthy hippocampus. I am suggesting that when there is a healthy hippocampus and you learn words, you are essentially able to watch a mechanism of learning and then semantic consolidation or integration that might be akin to other form of episodic learning. So that's one piece. The piece about fast mapping is intriguing because it was supposed to be like the promise of all learning. This is it. That's what's gonna be. But actually in children, so children are very good at doing these fast mapping processes, right? So you show them a cup and something that they don't know because they will look at the item that is new primarily. If you utter, ducks, they're gonna go for it and they're like, whoa, that's amazing. And that kind of ease in making that association is what has created a lot of sort of accounts that place language in this special place, and look how very young kids can do this, but those memories are forgotten very fast. So there are lots of paper that says learned but forgotten, meaning that actually they're not fully learned. They can recognize the association. If you test them 5 minutes later, they have no idea that there's association being it. So in children, ostensive learning, this is a DAX, is what seems to be more likely to yield to long-term retention. Same for cross-situational learning, other promise. How do children know that? I mean, right now, there is a phone and a bottle. If I don't know what they are and I say bottle, how will they know that this is the bottle? And then next time they see a bottle and glasses and they say bottle, like, there's a structural, a structural regularity, a statistical regularity. And it's true that toddlers infants are very good at seeing those regularities, but they are not retained. So if you're interested, they're lost so fast. It's pretty remarkable, actually. So it seems that children are endowed with, and infants, with a variety of ways to begin to map words and reference. No question about it. And it's even possible then that a developmental amnesia could do the more non-hippocampal sort of inferential, or at least, based on this kind of novelty signals and corresponding words. So it's possible, but the retention is the piece that actually gets tricky in young children. I would argue even older if I had the study done, which I didn't. But so I think that's the piece. Go ahead.
That was a great talk. I'm curious about the collection of studies where you've managed to get 2-year-olds and 3-year-olds to sleep in a scanner, which of itself is a feat. That should be a paper, the method, if it isn't already. But presumably, are you measuring actual sleep signatures simultaneously? Do you know?
Yeah, I always expect somebody to ask me that question, and I sheepishly have to admit that I don't. And there are a couple of reasons, although now we are trying to do a better job at it. Okay, so ideally, so this work initially was inspired by, the targeted reactivation type of work. Like, if they can reactivate, maybe we can take a picture in that reactivation moment to say, what's the status of the memory right now, right? So that was the idea. And of course, those reactivations in slow wave sleep, they are better. You can recover them better in slow wave sleep. So it really would be great to have a very clear signature. Having EEG added to this is a nightmare, and we would lose more kids. So in these studies, the first generation studies, as we call them, our evidence of slow wave sleep is literally, do they wake up if I move them, and some sort of temporal approximation based on studies that have looked at how long does it take to a child to be in slow wave sleep, and we wait that long. But this is all approximation, which is why we never talk about sleep stage in our papers, because we really can't say. We're trying to have procedures that homogenize, or the process that where we might hit, more likely to hit slow wave sleep, but we don't know. So now, though, there are new methods that are a little more, so still doing slow wave sleep sleep assessment during scanning we are not able to do that. But what we are able to do is there's a system. My God, I can't remember the name of the industry that we just bought the system from. So we're going to call it the system. And the system is one which is a band. It's not MRI safe. That's the problem. But essentially, a very simple EEG online sleep staging that we will be able to do in the next door from the scan and essentially say, okay, they are always asleep. Let's reel them in. So they will be already asleep. So what we do, and that's actually what we do all the time. So that's the process. The process is they fall asleep next to the scanning. We have a little lamp, a little crib, a little holder so that we don't, and then we put them in the gurney that actually is, they fall asleep on a gurney that is MR safe so that they can just be wheeled in. And then at that point, we can then remove the sleep band and hope that they don't wake up. So yes. And the truth is, if they are really asleep, they don't wake up and then they don't move, which is amazing, right? When you don't see the movement, you're like, they're dead there. They're beautiful. They're not moving. But I shouldn't say dead while I'm recorded, but they are very, very alive and happily sleeping. But they don't move. So it's very, so that's what's procedurally super enticing. I am not, I occasionally think about, we should do this this way. And then we're going to terrify these children and we're going to get 3 data points.
They won't stand.
They're not staying there at this age. With younger infants, I think is easier, but I don't know. I feel like, but we do need to perfect. Actually, not perfect. Start doing any form of sleep assessment, and then.
Can you use the bold volume to look at the actual eye movements?
Well, that is an interesting. We've thought about that too, but there are systems right now that do like videography. Really, they code for these kind of changes in respiration, and so we thought about that too. But right now, the idea is like the system, which I'm gonna between now and when we meet, I'll try to retrieve them. God, it's so embarrassing. Okay. Yeah.
Maybe just last from here. So to me, it really, can you clarify? So where do you stand about the chicken and the egg in generalization and specificity?
Mm-hmm.
And what do you feel all that you've learned tells us about what is episodic memory almost? Because you do episodic memory, but it's learning many repetitions. Fast mapping would be a single trial. Is that episodic memory or the many repetition?
Okay. No, it's a very good question. Okay. So first off, I'm going to say the single learning issue, in my opinion, is not what will is not the only is not a necessary feature. Single trial learning is particularly important when you're concerned that there's going to be some procedural learning that supports some retention. And I think that to the extent that you can still identify associative processes that link an object with something else that is arbitrary, that is about the context, I still think that is what's the sort of the component. I say episodic memory because that's how people understand what I study. But episodic memory in the Tolvinian sense is not what we're doing with very young children, right? And so what we're looking at are components. So it's component, the building blocks. So you need to have a system that retains information about a lot of events, a lot of features of an event in a way that is that capture that richness and arbitrariness, unlawfulness of human experience. But that in itself, an hippocampal representation is not an episodic memory. It's a building block of episodic memory. In my opinion. Then with regard to the chicken and an egg, that's about generalization. I think that, as we argued, Vladimir and I, is really about the fact that you cannot have a generalization from without a repeated exposure to something. What do you generalize to if you have never learned multiple instances of an object? And so, but then the idea is that what kind of memory do you need to have? You could argue that if you are super good at, so suppose you're an infant who knows nothing, but you have this incredibly sharp, resolute memory. And now you're presented with these two instances of two, dogs, and you are extremely good at remembering in every detail. You actually may find it difficult to generalize the concept of dogs because you're like paying attention to the specifics, you're remembering what's unique, and so you cannot see the common thread. Similarly, if you have zero exposure to multiple dogs, you can't generalize to, cannot learn a category. And so maybe the idea is that, a little imprecise memory can go a long way to enable generalization. So, I mean, I talked to Nora since she proposes like the generalization piece. I was like, and she says, well, if that's what you mean, imprecise memory, I'm like, well, of course, that's what I mean. I mean, I'm not saying that 2-year-olds will have a memories that are so precise, but the idea that there is some sort of like mechanism that since toddlers are tasked with this incredible task of learning about the world, they don't know anything, and so they would have a mechanism that is particularly good, more than other ages, at extracting meaning. I don't believe that. That I don't think there is any evidence to suggest that that's the case. But there are other ways of learning, for sure, of course. Yeah.
Any questions online?
No, there are no questions online.
So with that,
Thank you so much.